Hello, my name is Ben, and I'm going to be going over part 1 of trig identities. So, some of the identities in trigonometry we may have seen before. Sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, tangent being opposite over adjacent, or sine over cosine. Cosecant, of course, is 1 over sine, secant is 1 over cosine, and cotangent is either 1 over tangent or cosine over sine. Now, some people have commented before, why do you put the sine and cosine versions of tangent and cotangent out here? Those are one of the few steps that you can use to break down a problem and put it into a simpler form. Because sometimes, when you break things down into their sine and cosine components, you can eliminate quite a bit of the problem just by fractional elimination. To the side of these identities that we've seen, we have some Pythagorean identities. Sine squared plus cosine squared equals 1. Now, this falls directly from the Pythagorean theorem of a squared plus b squared equals c squared. 1 plus tangent squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. Now, on top of these we have our negative angle identities, which are mostly used when you're actually dealing with problems that have angles in them. You have sine of your negative angle equals negative sine of the angle. Cosine of a negative number equals the cosine of the positive number. And tangent of some negative angle equals the negative tangent of the positive of that angle. Now, I'm not going to sit here and try to prove all of these particular identities to you, but instead I'm going to use them in a couple of problems to show you how they can be used. So in this first one, simplify this expression to use a single trig function with no fractions. There are two real ways to solve these kind of problems. You can either try to figure out, okay, what identity can I go to? And if you can make it an identity, that's great. You have an identity that you're using, you can solve the problem real quick. If you can't make an identity out of it, bring it down to sine and cosine. Right now, I don't really see an identity that I can make out of this, so I'm going to bring it down into sine and cosine. So I'll start with secant is 1 over cosine. I'm subtracting cosine, and that's all over sine. You note I didn't put the theta in there. I'm lazy. So I'm going to concentrate on the top of this problem here because I see a fraction minus not a fraction. I want a common denominator. So I'm going to say 1 over cosine minus, well, cosine times cosine is cosine squared. Divide that by cosine. Put that all over sine. Okay, this is a little better. And I'm going to put sine over 1 because big fractions. So now we have this, I'm going to say 1 minus cosine squared over cosine over sine over 1. Okay. Now, when I see a squared here, I think, let me look to my identities here. So, cosine squared is present in one of these identities right here. But I have 1 minus cosine squared. So, I'm going to take my sine squared plus cosine squared, and I'm going to personally rearrange it so that I have sine squared equals 1 minus cosine squared. This is just me subtracting the cosine from both sides. So, given that 1 minus cosine squared equals sine squared, I'm just going to do a straight replacement. So now sine squared over cosine over sine over 1. Now it comes down to how do you work the fraction. Now all of these trig identity problems are really going to be working your understanding of algebra and how to solve an equation. So right now we're dealing with two fractions. I'm going to keep the top half, change this big division symbol to multiplication, and flip this fraction upside down. Sine squared over cosine is the keep, times, and I'm now going to flip this so that I have 1 over sine. Okay, I think I see an elimination. Sine and one of the powers of sine up there. So that's what I'm left with, sine over cosine, which of course, from our trig identities, is tangent of theta, because theta is our symbol. So that's my answer for this one. Now, this is just breaking it down using fundamental fractions, identities, and elimination to solve this problem. Next problem. Show that this identity is true. Cosine squared x over 1 plus sine x equals 1 minus sine x. A lot of ways that I could potentially do this, but one that I see offhand is common denominators. I see a sine, I see a sine, I see subtraction, I see addition. If I can make this a sine squared, my Pythagorean identity, if I subtracted sine from the sine squared plus cosine squared, I would have 1 minus sine squared equals cosine squared. So, knowing that 1 plus something times 1 minus something gives me the 1 squared minus whatever it is squared, I'm just going to use that as my method of getting to an identity. So I'm going to say cosine squared over 1 plus sine equals 1 minus sine times 1 plus sine over 1 plus sine. Now, here I'm actually going to use common denominator rule. If we have the same denominator on both sides, and it doesn't matter what variables they are so long as they are exactly the same, I can say I ignore the denominator and can concentrate on the numerator. So, let's go with this. Cosine squared equals 1 minus sine times 1 plus sine. So, next thing, I'm going to have to FOIL this. So first, 1 squared. That's just 1. Plus sine. And then inner minus sine. And then last. So minus sine squared. See where this is going? Plus sine and minus sine cancel. So cosine squared equals 1 minus sine squared. And that is literally a slightly rearranged Pythagorean identity. So, since we know that that Pythagorean identity is true, this identity has to be true because we can get it down to here. Hope that you got something out of this, and enjoy.